Hello, everyone. Welcome to our next session. The This next session up is our second session of the conference about WASM. This is about both WASM and WASI, which our speakers will explain. So it is my pleasure to introduce Giuseppe Scrivano and Aditya, who are going to explain all about that. So welcome, folks, and go ahead.
Yeah, so hi, so I'm Aditya, and along with Giuseppe, today we are going to be talking about WASM WASI and the cloud ecosystem. Uh, Giuseppe is author of the OCI Runtime CRUN, and I'm one of the maintainers of OCI Runtime CRUN. Just a disclaimer. So this session is specifically going to be around the OCI runtime and WebAssembly aware OCI runtime. We yesterday had a session by Scott with the state of OCI, and he gave a demo around how OCI containers are leveraging WebAssembly. This talk is a little bit different from that. It's more about how the OCI runtimes are leveraging the tech to actually run the WebAssembly workload and why we decided to do that. So before we start, I'd like to quickly discuss like what is WebAssembly and its origin. So web browsers used to speak and understand JavaScript for all their needs. Like most of the interactive applications today, they use JS to toggle and interact with the users. But the problem with JavaScript was that browsers actually read JavaScript and perform JIT generation of the bytecode. And the whole process of reading the code and converting it into the bytecode and running it was a little too much for most of the performance intensive use cases, like running high-end video games and some of the simulation tools. So there was a need for something which can bypass this route. So the most obvious way was a pre-compiled bundle which can be fed to the browsers, and browsers can directly execute it on the host machine in an isolated environment. So that's how the WebAssembly came into the origin. So in a formal definition, you can call WebAssembly as a standardized bytecode format for executing programs that any WASM runtime can execute. Here, the WASM runtime, I'm specifically calling out browsers. So if you see the definition, is it like it sounds very much similar to what Java does, right? Because you have a Java code and you convert it into a bytecode and JVM runs it. Uh, at the top level and the abstract level, yes, they are like similar, but the domain of WebAssembly expands in a much broader way. It is much more standardized and not scoped to a particular language. So more than one languages can actually generate the WebAssembly binary. Although initially it was written for C and C++. So here is a link of like high-level goals. So if you see high-level goals, you can see that initially it was only for C and C++, but later on, multiple languages added the support for WebAssembly compilation. So even I think Go is working on that, and Rust actually has a full-fledged support for it. So it actually makes sense for browsers that browsers needed something which has strong security and small binary size, because you quickly want to download and execute the things, fast loading and running something which is already compiled, not too much of size, and cross OS and cross architecture, because like browsers should be agnostic of hardware. The underlying phones are changing quickly. Each phone have their own operating system, so everything made sense for browsers. But if you see closely, is does the needs, do they align with the cloud ecosystem as well? So we think yes, because if you see closely, the very much the container actually checklists some of the points, and some of the points actually very much fits with what cloud ecosystem needs, and they do not have it right now. So for example, strong security is still needed. I think container actually fits well here. Small binary size, this is actually debatable, but I think WebAssembly might fit here. Fast loading and running. So WebAssembly modules are actually very lightweight in themselves if the WebAssembly runtime is removed. And cross OS and cross architecture. This is very important point for cloud ecosystem, because every other day the new hardware is getting introduced, a new node group, which is much more efficient and cheaper, but the cost associated to the migration of workload is too much, because the developers, they are unaware of the of the architecture where the code is running. So they assume that by default it is a standard architecture. So the migration from a particular hardware to another is a costly process, and it might involve instrumenting the application code again. But WebAssembly actually has a solution for it, because WASM runtime actually does the heavy lifting, and it actually runs the workload on the hardware, so the code can stay intact. But the application on host is fundamentally different from web. So yeah, so if you see it, actually it is very easier for things to run on browsers, but the host application, they are much more complicated. They do tons of things, they do make system calls, and they have very much operational needs, which is different from the applications which are running on web browsers. So how does it work? What is the magic here? So the team which was actually working with the WebAssembly, a subgroup was created where they were working on creating an interface which is called WebAssembly System Interface. So or the short form is WASI. So treat WASI as an interface in programming language. So for example, you have your host application. What does host application? Let me lay out a very simple host application, which is an executable. It opens a file and reads out the contents of the file from the host. So a typical application is making a OpenSys call. It returns a file descriptor and reads out all the contents in a buffer and just prints it to the user screen. But this should be WebAssembly runtime should be aware of all the syscalls which are available on the OS. So treat WASI as an interface which tells the WebAssembly runtime to implement all the necessary system calls. And when the host program is compiled into a WASM module, as per the WASI standards, the WebAssembly runtime will know like what what calls needs to be converted for what OS and at what time. So there is a small diagram which depicts the actual use case here. So if you see the diagram, your actual WASM module is written, and your actual system call is converted into a, a spec defined by WASI. So for example, your actual host program was using an open call, and WASI spec actually lays out defines an API for open call. So it will be automatically converted into the WASI spec. And since your code is actually converted as per the WASI spec, so WebAssembly runtime will know that what it has to do for a specific implemented API call. So for example, it's open. So all the WebAssembly runtime will know that how to implement open for all the relevant operating system and the architecture. So your actual code is at much higher level, and all the heavy lifting is actually done by the WASI and WebAssembly runtime itself. So you are just writing the code, and the WebAssembly runtime is doing the stuff. So that's how the applications on host is gonna get executed. And I think this is a powerful way to make programs agnostic of the operating system and architecture. So this is the whole WASI concept, and I've discussed from a much higher level perspective. This has like more details to it, but we can discuss it in Q&A, or maybe on somewhere in the open thread, because it's a very deep topic in itself. So let's move ahead to our actual crux, which is Crun's WASM WASI implementation. So if you're working with any container infrastructure or container tooling, the most fundamental layer of your entire ecosystem is the OCI runtime, or the container runtime, which actually spins the container and runs the workload. By fundamental, I mean uh, the lowest unit of your entire hierarchy of a container infrastructure, apart from orchestrator and the shim. So one such OCI runtime is Crun. If you don't already know about Crun, so if you're using Podman, most likely you are using Crun. If you're not using Podman, you are most likely using Runc, or any other of the contemporaries. And if you're not aware, most likely you are using Runc if you're working with Docker or any other orchestration tooling like Kubernetes. So Crun has this design where it can allow it can allow developers, the Crun developers, to delegate the workload to other implementations at a much lower level. So in the layman terms, treat it as a design system where Crun will actually create the container, and when it is about to offload the work where the actual exec calls happen, it allows developers to create custom handlers for it. So one such handler which we worked on was WebAssembly handler. So what WebAssembly handler does it is that it allows Crun to create a basic container layer, and as soon as the workload is about to get executed, it delegates it to a WebAssembly runtime, which can be WASM Edge, WASM Time, or WASMer. So Crun actually supports all three of them. And shout out to WASM Edge second state folks, because they actually helped us implementing WASM Edge handler, and similarly to all the maintainers of WASM time and WASM as well. So why do we think that CRUN actually needs to do it, and not why not OCI images themselves can carry the WebAssembly runtime? So if you see, in most of the cases, the actual workload, the compiled WebAssembly module is very small, from few KBs to few MBs, and there's no need to ship or carry along a bloat of WebAssembly runtime when it can be actually provided by the host by default. And in fact, I believe that in future, like most of the hosts will have a very default and native WebAssembly runtime inbuilt in future. So this is an assumption that actually hosts will carry the WebAssembly runtime, and application containers don't need to do it. They can create lightweight images from scratch, and it can only contain the WebAssembly runtime. So treat your application as few KBs of a container image, and it is actually being executed on the host. So we are relying on CRUN to do the heavy lifting and actually run the WebAssembly workload. So this was the whole design. Like, the question is, can we use this currently as of now in Kubernetes on Podman? So yes, very much that is possible. So if you're already using a Kubernetes cluster in production, and most likely it's not using CRUN, it's using runc. So you can ask your administrator to create a runtime class, and you can actually have a dedicated runtime class for CRUN, and you can run WebAssembly workloads on your Kubernetes cluster right now. So if you open the CRUN's GitHub repo, you can go to docs directory, and we have a dedicated markdown file for how to run WebAssembly workloads on Kubernetes. And if you're using Podman, you just need to bump the versions on Fedora, and it will by default support running WebAssembly workload. So Podman actually does it by default, and if you're using an older version, then it will not work. But if you can update it, for sure, you will have support for running WebAssembly workload. So now let me show you how a sample example looks like. Yeah, so I have just skipped one slide ahead just to showcase how the sample example will look like. So if you see Docker's technical preview, so I have picked up the same image as it is. So there's a feeling that there's no difference in the underlying infrastructure. So this simple command here actually runs the very much container which Docker uses in their technical preview. So you can just copy this command as it is and run it. So I'm not going to run it here because it will be more ideal if people do it manually by themselves, and it will give a better taste of how easy is it to run actually the WebAssembly workload with Podman. So this is the expected output that your server will actually run, and it will expose port to 8080. And if you go on your browser, you hit the 8080, you will actually see that your WebAssembly module is being served there. So this is something which I want everybody to try out. And you can actually, I'll paste this command after the session in the chat, so you can actually update your Podman and try it out. So one more important point is like why we think that this problem is legit, because we are not the only one who are trying to solve this. There are a bunch of other solutions out there who are trying to solve this very much similar problem in a different way. So there was Crustlet, which is, I'm not sure if it is actively being used anywhere or not, but it had a similar idea where the whole scheduling was based around the WebAssembly workload, but they quickly shifted to Run WASI, which is a containerd like shim, which actually delegates the workload to WASM time. So this is also similar to CRUN, but does the delegation at much higher level. So we have few more, like Docker does it similar to Run WASI. They have a shim where they delegate the workload to WASM directly instead of runc. So why we think that CRUN's approach is a little bit different, but it has its own perks. So let me talk about the perks why we think that CRUN's approach still fits and still is applicable in a lot of cases. So the first one is implementation and maintenance cost. So I think it's easier to add a runtime class to your actual Kubernetes cluster rather than implementing a shim. I could be wrong there, but I think adding a runtime class is very much a standard. So it's easier to introduce a new runtime and create a runtime class. So I think implementation is easier on that part. But if you think otherwise, let's discuss in the chat. And one more perk which CRUNs offer is that CRUN still creates the very much outside container. So in the run WASI's approach and in the Docker's approach, the whole container infrastructure is gone. They are directly delegating to the WebAssembly workload, while Siren still creates a very much thin layer of container outside. So all the security checklists which you were sure of in the container infrastructure will still be there with Siren's approach. And if you had a complying tooling or a validation checklist which were honoring certain criteria as per the containers, so Siren will still go through all of the checkpoints. And one more perk is that I don't see as of now the resource control knobs for the WebAssembly workload. While in Siren's approach, since a outside layer is still made out of a regular container, the very much resource control knobs for C groups are available. So you can actually set the maximum memory or the maximum number of CPUs allocated to your WebAssembly workload. So that is still available, and I think it's a very big perk if your compute cost is involved. So yeah, this was the major idea, and this is a simple example which I think you should play around. And we actually wrote like a detailed blog on this. The first link actually points to that, which actually talks like everything in detail. And I have also listed some of the docs, which is the manual pages, how you can actually build Siren with WebAssembly support, and some tryout examples which you can play around with to get comfortable with it. So this is the whole idea of what we are working in and why we think that this has a future. So yeah, so that's pretty much it. Let me know if you have any questions. I'm gonna stop screen share.
So we have a question from Dan. Could I run WebAssembly in Quadlet as a systemd service?
Could I run WebAssembly in Quadlet as I think yes, it's possible. Like how we run a web server in Podman, I think it's very much easy to actually create a Quadlet service, because actually from Siren's perspective, it's just a container, and the delegations happen at a lower level. So I think it is very much possible to do that, but I haven't actually tried it out ever. So
yeah, I expect it will just work as any other container. Also, if you specify the different runtime for Podman, or the arch will be read from the image. So there is also it won't be necessary to specify the arc on the run command as it was in the demo. Another question from Dan. When will WASM be available in OpenShift and RHEL? Well, that depends on us when we are able to drop the. We have a dependency on Python now and WASM that it's blocking adoption in CoreOS. We are working on that upstream. So once we have the WASM in CoreOS, we will be able to use that from.
Aditya.
Yeah.
Now that you're not presenting, you want to turn your camera on?
Yeah, let me try it actually.
Okay.
Can you?
There we go. Yeah,
okay.
That's good.
Okay. So there's another question, like, are there any blogs about people doing a lift and shift style thing from containers to WASM? So I don't think like we have any direct way. I think the whole design paradigm of how WASM applications are written is a little bit different. So if it's a server or a very much a web service, so I think it is straightforward to do the conversion, but there's no rough guideline how to lift and shift your existing containers to WebAssembly workload. I think this is something which has to be done at the fundamental development level, like compiling your web server into a WebAssembly binary and then creating a container out of it. But I think this is a really good idea to actually start working upon, because this is something which is important from migration perspective.
Yeah, so we have another question from Heidi. Does WASM have different arches like x86 ARM? Well, in my opinion, this is the biggest advantage of WASM, that it doesn't have an arch and it works similarly on the on different arches. And this is the advantage of having the WASM interpreter inside the Scrivano, so that you can build just one image targeting WASM, and you will be able to run it on different arches. Differently than what you do now. What it's supposed to be done now when you multi-arch images. You still need to build one for each arch.
Yeah, and I think here the question would be more around the support of WebAssembly runtime for a particular architecture. For example, if the WASM time actually supports the RISC-V, you can actually assume that it will run any generic WASM module on the RISC-V, agnostic of how the code was written. If your code is written in Rust, you can actually generate a WebAssembly module, and the WASM time itself supports different architecture, assume that it's going to run. So that is what I think will happen. There's another question from Anders, like, what are your thoughts on workerd? For this, I think what Crun is trying to do is it to create a migration path for the native containers users to actually WebAssembly. I think workerd is a different paradigm in itself. It's I think more like a function as a service kind of thing, because I'm not entirely aware. But the Crun's idea is to actually allow the users of existing container infrastructure and run the WebAssembly workload as it is. So just a migration path. It's not actually a replacement of workerd. I think workerd is a different segment, and it is very much useful in its own place. I don't see how Crun is actually compared there. But Giuseppe, let me know if you have any thoughts on that.
No, I'm not really familiar with workerd. I mean, I know about it, but I never use it, so I'm not able to compare. Another question from Dan: do you think we could do something similar for Java apps and Windows apps using Y? Yes. Well, the mechanism we have in Crun, we've initially added to support libkrun. Like, instead of running a container, we were running a virtual machine. So it's a quite simple idea, because in practice we just replaced the exec to the container process with something else. In the libkrun use case, we run a virtual machine. So we have a virtual machine inside the container, and that was easy then to extend with WASM. We ended up adding 3 different backends. In theory, we can add other stuff, and then each of them has their own difficulties. For Java in particular, it's more about how all the entire dependencies must be presented to the Java app inside the container. And for Windows, it also, as you were saying yesterday, it's also depending on the file system, because Windows apps are case insensitive.
Yeah, we added a handler for Mono, which actually allows users to run .NET workload on their Linux containers. So we do have a native support for Mono. So Mono actually allows users to run .NET workload both on Linux and Windows. So I think we added support for that, and we actually tried adding support for Wine, but we were hitting some of the blockers related to file systems and how the Wine was built in itself. Like, there was no embeddable support, which I could find. It was like a very big package with shared libraries, so it was very hard to actually figure out how it can be integrated with Crun, and there were some limitations and blockers which we faced while trying to actually do that.
So we're waiting for more questions from the audience. I actually have a couple of questions, an easy one and a hard one, I think. So the easy one is, how are WASM binaries supposed to be distributed? Would they be like wrapped in a container image and pulled via the container runtime?
Yeah. So my take on this is that I think even if you see the solution which Fermion is giving right now, they are trying to use OCI artifacts for this. They had a different format called bindle before this, but I think it's deprecated now. So I do think that they will be shipped by the OCI images and OCI artifact themselves, but the CRUN's approach actually consumes the CRUN is actually runtime, and the top level managers like Podman, they actually consume OCI images. So they will do OCI artifacts as well. So I think both should be supported. And as of now, like I'm assuming it's going to be either OCI artifacts or OCI images in journal, where they will actually contain Scratch based base images and actually the module as the entry point.
Okay, now here's the more difficult and sort of, wide view question, and Dan bringing up Java actually made me think of this, which is back in the peak sort of J2EE days, there were a number of attempts to do basically just this using Java, using enterprise service bus and distributable, precompiled jars to have automated application distribution and execution across clustered machines. And there were a number of startups that actually were built around this idea. And again, we're talking about mid-00s. And none of these were successful technically. None of them actually saw wide adoption or commercial success that I know of. So one of my questions here is, what makes WASM different that we can tackle this general idea again, write once, run anywhere, distribute everywhere, and have it work this time?
Giuseppe, do you want to take this?
I don't know what will be. Now, it seems to be the thing of the moment. I hope that it's much simpler than Java bytecode. So this is the first difference. And also from our point of view, it still runs inside a container. So differently than a Java hub that, the common denominator was just the Java runtime, but still the entire host will be different. In this case, the host is still the same. We are just taking the multi-arch part, which is simpler. Being more limited, will make it simpler. From my limited experience writing something with WASM, it's like it's still missing a lot of APIs, even for basic stuff. So
one thing which I think that the whole idea around WebAssembly is that it starts from a very open perspective, and the standardization in general where multiple languages can actually inherit and produce the WebAssembly binaries, while the Java was actually restricted to the Java itself. So that is one thing where I think the adoption will be actually very quick, because you are actually generating the compiled binary from various languages, not a single language. And one more thing which I think, although as Giuseppe said, like the API in itself of the WASI which I talked in the slide, it is not complete in itself. By complete, I mean not all the runtimes actually implement all the necessary calls, like the networking part, which I know as of now, it's not properly implemented in all of the WebAssembly runtimes. So it does have limitation, but I think it has very open standardization from the beginning, and not isolated to a language or to a community, where multiple ecosystem can actually collaborate and they dwell on producing a standard WebAssembly bytecode. So I think that is one of the major perks, which I believe, and it will allow users. It will allow it to last longer and maybe become a new standard in future.
Okay.